Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about sequence and series of the function. Remember, we are not talking about the sequences only, we are talking about the function. We will cover all those questions from the year 2011 to 2023 from the CSIR NET examination. Myself Dr. Harish Garg, you can simply follow my YouTube channel where you can find the various PY question series. We will cover all those questions from the part B and part C with the help of the sequences of the function. We will cover the 35 plus question with the help of shortcut trick. You can scan and join my WhatsApp group. You can simply scan this WhatsApp code and you can join this my group for the various discussion part. Firstly, before solving this, I will tell you the simplest shortcut tips how you can solve any of the question related to the uniform convergence. We will cover about the sequences and the series. Whenever there is a question related to the sequence and series, you always try to find the limit of this function fn. If it is not continuous, it means it is not pointwise convergent. If it is not pointwise convergent, it means it is not uniform convergent. So the one simplest step is, if you want to prove that the sequence is not uniform convergent, you just prove that the limit is not continuous. On the other hand, if you want to prove that whether there is a uniform convergent or not, then there are the two methods. One is for the sequences, second is for the series. When the question is related to the sequence, you always try to find the MN test. That means you firstly find the function by using the limit of this and define the term as of this over the domain X. If you prove the supremum of this goes to the 0 as n approaches infinity, then you can say it is a uniform convergent. Otherwise not. Remember, it must be goes to the 0 only. If it is goes to the 1, it means it not goes to the 0, then it is not uniform convergent. On the other hand, whenever you are talking about the series, then you always find some series or which is less than of the hx and prove that this is a convergent. How you prove that the series is convergent? You may apply as a root test, you may apply as a ratio test, you may apply as a nth p or p term p test, you may apply as a geometric series test or any one of them. If you prove that this series is convergent, then the given series is also uniform convergent. On the other hand, if you are unable to find this hx, then you can find the nth partial sum sequence and prove that this limit existence and continues. So based on these simple tips, you can solve any of the question related to the uniform convergence. So make sure your target is to firstly identify whether it's a sequence or series. Then you can apply the simplest approach here. Look at this one. So first of all, you can see this is a sequence. It is not a series. Then your target is to find the value of fx as limit n approaches infinity. So what is the domain is? 0, 1. What is the limit when x is equal to 0? It's a 0. What is the limit when x is equal to 1? It's a 1. What is the limit when x lies between 0 to 1? It is again a 1. So is it a continuous function? Not. It is not a continuous function. What is the meaning of that? It is not a continuous. It means it is not pointwise. If it is not pointwise, what is the meaning of that? It is not uniform convergent. So look at that. It converges uniformly. It defines a continuous function. Limit is 0 for all n, but we get this is a 0 when it lies between 0 to 1. Yes, it is a 1 because it's a power 1 by n. So it's a 0 for all. It is not true. So this also cancel. Limit existence, yes, limit exists for all x. So that's the right answer of this problem. Again, you can see this is the sequence. Fine. So your target is to firstly find the value of fx. So what is the value of the fx? Domain is when x is equal to 0, answer is 1. When x is equal to 1 by n, the answer will be 0. Whenever x lies between 0 to 1 by n, limit is again 0. Whenever x lies between this, answer is again 0. Again, you can see it is not continuous. So the first option is cancelled. If it is not continuous, is it a uniform convergent? No, it is not uniform convergent. Limit is 0 for all x, but we get a 1 limit which is non-zero. So this option is also cancelled. Limit existence for all is my correct answer. Look at this another one, which is again a sequence. Fine. So you can define a function f of x. What is that? When x is equal to, domain is my 1 to 2. When x is equal to 1, what is the limit of this? When x is equal to 1, it's a 1 minus. When x is equal to 2, this is a 0. When x lies between 1 and 2, answer is 0. It is not continuous. Is it a continuous? Not. Is it a uniform convergent? Not. So first two limits are cancelled. Look at that limit of the fn. What is the right hand side limit? You can see whenever it's a 1 to 2, the answer will be 0. Fine. Look at the left hand side. What is the limit integration of the fn x? So if you take the integration of this, it's a 2 minus x of n plus 1 divided by minus of n plus 1. So limits are my 1 to 2. So when you take 2, it's a 0, it's a 1 over n plus 1. It goes to the 0. So this goes to the 0. This goes to the 0. So it means left hand side and right hand side are same. Now look at that. Firstly, we can find the f dash. What is the, if, okay, a can be any number. A can be any number between them. Okay, so I can simply choose a as a midpoint of this. Fine. Then what is the f dash of 3 by 2? So firstly we need to find the f. What is the f dash? 3 by 2 lies here. So this value is my 0. What is the left hand side? We can find the nth f of n. What is the derivative of this? Minus 2, 2 minus x of n minus 1. So at the point of any point a can be 3 by 2 or anything. It is my 2 minus a of this. So at the point 3 by 2, it is minus, it is my half of n minus 1. So 1 by 2 is the common, it can be written as of. Now clearly says it goes to the 0 because 2 raised power n growth faster. So this is a 0, this is a 0. It means both are equal, but he said not equal. So this option is also cancelled. Right option is only my C is the correct option. Okay, look at this another one. Again it's a sequence. The necessary and the sufficient condition for this converges to the 0 is here. Oh, very simple. Can you choose any of the function Bn whose limit is 0? I can choose here. Cs I again can choose here. Fine. Then your target is to prove this goes to the 0. Fine. So how you can choose that? Because this is x square, so I can choose Cn is my x square. Okay. So take x is my n. So what is the fn? Fn is 1 plus 1, which goes to the 2, which is not goes to the 0. First option is cancelled. If this is cancelled, so third is also cancelled. Fine, because in this case limit of the Cn goes to the 0. Now look at this is a finite. Any of the term who is finite, so I can simply take is my GP series. And Cn again a finite because it's a square, I can simply take as a square of this 4 raised to power n. So clearly says this is my GP series, which is my finite. This is my GP series, so it is again a finite. But what is the fx? And what is the I can take x is my 2 raised to power n. Fine, for any of this x. So what is that? It is a 1 plus 1. Again it goes to the 2, which is not goes to the 0. So this option is also cancelled. Remaining is my C is my correct option of this problem. Okay, now again this is the sequence. So you firstly find the value of the fx. What is the value of the fx when n approaches infinity of this? So when n approaches infinity, it goes to the 0. Fine. So what is that? It's a continuous function. It means it is my point-wise convergent. But they are not talking about the point. Okay, so it means f of n is converges to the 0, but he said f of x is cancelled. This is cancelled. Now you have to prove is a monotonic or a non-monotonic. What is the meaning of the monotonic? You have to take the derivative. So what is that? If you take the first derivative of this, it's a minus 2x over n square plus x square. It is over whole square. It is always less than 0 for all x belongs to the domain. Fine. So what is the meaning of that? Fn is my decreasing sequence. If decreasing means that is a monotonic sequence. So if it is a monotonic and converges to the 0, so this is my right answer. This is the wrong answer. So A is my correct option. Okay, look at this another one. A sequence, again this is the sequence to firstly find the value of fx. So what is that? If you take the limit n approaches infinity, so this is x over e raised to power n x square, it goes to the 0 for all x belongs to the R. So fx is my 0. So then you define the mn, which is my supremum of x e raised to power minus x square minus 0 over the domain. So how you can find that? If I simply take y is equal to x e raised to power minus x square, find the maximum value, y dash is 0. So e raised to power minus n x square minus n 2n x square e raised to power minus. This is the derivative of this. So what is that? If I take e raised to power n square common, 1 minus of this is 0. So x square is my this value. So what is the value of the mn? So this is supremum 1 by root 2n e raised to power n minus of half. It clearly shows it goes to the 0. So if it goes to the 0, what is the meaning of that? It is my uniform convergent over the whole x. So it is a uniform convergent on the complete R. Fine. It is uniform convergent on the closed and boundary, but he said only, but that's a wrong option. It is not uniform convergent, wrong option. It is unbound because it is a sequence of the uniform convergence, it's a bounded sequence. It is my, so right answer is my A at the right answer. Okay, again this is a June 2019 part C. Again this is the part of the sequences. Fine. So your target is to find this limit of this. Remember, when you always try to identify whether it's a sequence or the series. If it is a sequence, start with the limit of this. So when x is equal to 0, what is the answer of this? When x is equal to 0, it is a 0. Fine. So it means when x is equal to 0, answer is 0. And whenever x is non-zero, then what is the limit? Because the degree of numerator is less than of the degree of denominator, so the answer of them is again a 0. Otherwise it's a infinity by infinity form. You can apply the L'Hopital rule, so it will be, it's a 2nx square. Again it goes to the 0 whenever x is non-zero. So what is the meaning of that? It is a continuous function. It implies it is my pointwise convergent. Fine. Pointwise convergent does not means that it is not, it is it's a uniform convergent. So it's a pointwise convergent. Yes, it converges to the x, wrong, because it converges to the 0. These options are cancelled. Now you define the mn, which is the supremum of all those x, such that g of x nx over 1 plus n square x square minus of this. So that is very simple. You can simply take the denominator as a 0. So it will be nx is minus 1. Ignore this plus minus. Ignore this plus minus. So x will be 1 by n. If you substitute here, what is my supremum of this? 1 over 1 plus 1. It is 1 over 2, which is not goes to the 0. It means it is not uniform convergence. So it means this option is cancelled. Right option is A. You can always take the denominator as a 0, find the value of the x. Second method, you can simply take x, y is my this. Fine. Then you can find the y dash is 0, find the value of the x. Again you will get the same of this one. But there is no need, you always take as a denominator as a 0, find the value of x, ignoring the plus minus sign. Now again it's a part B question. Again they are talking about the sequence. Fine. And the options are related to the subsequence, subsequence, subsequence and the subsequence. Fine. E is the collection of all those n such that n is my natural number. Fine. That means 1, 1 over 2, 1 over 3 and so on. Fn is the sequence which are defined like this way. You have to take the subsequence. I think very simple. Okay, for every point, every point, every point, every point. Okay, so if I take any point x belongs to the E, what is the meaning of that? X is of the form 1 by n. Fine, clear? So what is the meaning of that? I can found a one number, say n0, which is a natural number, such that x is my 1 over n naught. You know why? Why? Because we can use the Archimedean principle. Fine. So once x is greater than of the 1 by n naught, so which property is satisfied? Here. So what is my f of at this point n naught? This is my cos of n naught of x. Fine. Now what is the meaning of that? It means this is for all m which is greater than of n naught. So what is the meaning of that? This is my bounded function. Fine. So it means there is a sequences. We can find a sequence like of this. We can find such sequence. These are bounded, so no subsequence, cancel. Every subsequence converges at every point. This is not true because we have, okay, firstly we can see there exists here which converges to the 0. This option is cancelled because it's a cos. It may or may not be converges to the 0. It converges at every point. There exist infinitely many subsequences. Yes. So now you can see that it implies it is a bounded. So it has a convergent subsequence. So how you can move from the bounded to the subsequence? Do you know any of the result which moves from the bounded to the subsequence? That is a Bolzano-Weierstrass theorem. So this means what is the meaning of that? There exist infinitely many such n-zeros. So this option is cancelled. Right option is only C is the correct answer. Okay, what is that? F is the sequence of the real value function such that f of n converges to the f for all x. It is not given that it is a uniform convergent, and it means this is my pointwise convergent, and f is said to be integrable. Fine. So very simple. As I already told you in my previous PY question series tips, if f is, what is that? But how you can prove that this is a uniform convergent or not? Okay, f converges uniformly here. F converges uniformly on the closed interval a comma b. Remember that on the closed interval a comma b, whenever limit of this as n approaches infinity is my limit of fx, where fx is limit n approaches of this, and it is already given to be here as a pointwise. So remember, it's a closed interval, but it is not a closed interval, so this is not true. This is the closed interval, so if it is converges uniformly, this implies here correct option. Fn converges uniformly, but they are not closed interval. This option is cancelled. This is a closed interval, so this implies here because you already stated here. So these are simple tips. You can see B and the D are my correct option. It's a part C question. Okay, look at this another one. This is again the part C, which is consists of more than one correct option. An is a sequence. First of all, this is a sequence. Fine. G and H are defined to be here, and this is just like say characteristics function. Fine. So okay, firstly look at that first option. If G is equal to H is equal to 1, what does implies that? G is equal to 1, H is equal to 1. What is the meaning of that? supremum of xi is infimum of xi, both is my 1. What is the meaning of that? This xi is converges to the 1 because it's the infimum and supremum, both are same. What is the meaning of that? There exists at least one x such that xi of this is my 1. So what is the meaning of that? X belong, if xi is 1 means, what is the meaning of that? X is belongs to my a of n. So there exists a m is my correct option. Look at the second option. If g is equal to 1, h is equal to 0. What is the meaning of that? Firstly, I can think about it. If both are not 0, if g and h both are 0, it means supremum, infimum, both are 0. It means this function xi is converges to the 0. What is the meaning of that? X does not belongs to the a of n. So x does not belongs to the a of n, again is the correct option. Now g is equal to 1, h is equal to 0. What does it mean? If g is equal to 1, h is equal to 0, it means supremum is my 1, infimum is my 0. What does it mean? It means there exists one x such that supremum, that means xi is converges to the 1. Xi of x is my 1. If xi of x is converges to the 1, what does it mean? There exists m, there does not exist m. What, how you can say that? You can say, so okay, when infimum and supremum are not same, what is the meaning of that? This is my not continuous function. Fine. So now fine, this is correct. If this is not a continuous function, then we can prove by contradiction. If x belongs to the an, what does it means? That it means there exists some m which belongs to the here such that xi will converges to the 1. But he said supremum is 1 but infimum is 0. It means it is a contradiction. So what is the meaning of that? B option is cancel out. So therefore this option is cancel out. Now what can you say about the C part? Can you say if here, then there exists a sequence of the natural integers, that there's a subsequence. Basically this is a subsequence. So you can define the subsequence easily such that this condition holds. So the right answers are A, C and D are mine. Because this is a subsequence. Subsequence you can define only one sequence, 1, 1, 1, 1, which can satisfy. But in this case it is for the sequence. Sequence is not existence. Okay, look at this another one. F is a sequence of the continuous function. So which of the following is satisfied? You can take any of the sequence of the continuous function. The simplest one is 1 over n, which is a continuous. Fine. Over the r, because the limit is goes to the 0, is a continuous function. Now look at that. Is there pointwise? Yes, because if you take the limit as n approaches infinity, it goes to the 0. It is a continuous. It implies it is a pointwise. Fine. So if it is a pointwise, now look at that. What is the limit of this? F is my 0. So this value is my 0. What is the left hand side is? Minus infinity of this. What is that? It's a log of n is not defined. If it is not defined but the right hand side is a 0, it means this must be not equal to. So this option is cancelled out. Again, 1 by n is a pointwise convergent. It's a sequence. If you define this as here, clearly says it goes to the 0, it means this is a uniform convergent as well. But again this result not hold. Again the same example. C option. Fn converges to the f uniformly convergent. So what is the meaning of that? If Fn converges to the f uniformly, it means f is continuous. Fine. So that means if f continuous is the correct option. There exists a sequence of the continuous function such that f of n converges to the f uniformly, but this does not existence. So there exist. They are not said that for all. They said there exist. So there exists. I can simply take this sequence. This is a sequence of the continuous functions such that the limits are not equal. That's a correct option. So C and D are my correct answers. Okay, look at this one. It's a part C again. Fn converges pointwise. Fn, you are talking about the Fn. So look at that. First of all, this is a definite. So limits are my definite integer. Fine. So it means Fn is my uniform convergent if and only if Gn is my uniform convergent. This rule is applicable only when the limits are my definite. If it is from 0 to infinity, then we can't say that. Then our target is checked for the Gn only. So firstly, it's a sequence. We can find the limit of this Gn. So when x is equal to 0, what is the limit of this? What is that? As n approaches infinity, so it is my sine square x. It is my continuous function. It is a continuous function. It means it is my pointwise convergent. Then you define the m, supremum of all those x, such that sine square of x plus 1 by n minus of sine square x. Then I can write this function as sine of, that is a square minus b squares, a minus b and a plus b. Fine. Then your target is to find over the supremum. Then we all knows what is the sine of x minus sine of y. Absolute value of this, it is always be less than of x minus y. So I can take this as a x minus y, which is 1 over n sine of x plus 1 by n plus sine of x. Fine. Now clearly says as n approaches infinity, it goes to the 0. So once it goes to the 0, it means G is my uniform convergent. If G is my uniform convergent, it is my Fn is my uniform convergent. But he said it is not convergent. Cancel. Does not convergent pointwise. Cancel, because it's a pointwise. It convergent uniformly. Now it is a 0 1. It is 0 for all x. So what is the meaning of that? X is my 0 to infinity. This is 2. If it is for my 0 to infinity, then it is also uniform convergent over the 0 to 1, because it is for the all x. So the right answer is my C and the D are my correct option of this problem. Okay, let small t and a are my positive real numbers such that this is which of the following statements are my true. Look at that. Answers are not depending upon the a. Answers are not depending upon. Okay, very simple case. I can simply take n is my 1. Fine. Then your b of a, it will be collection of all those x such that x square is less than of a square. Fine. Or you can say collection of all those x minus of a is less than of a. Fine. Now look at the first option. Integration over this ba. So that's a minus a to a f of tx of dx. So how you can do that? Or this is my b of a. So I can take t of x is my y. So d of x is dy over t. So what is that? This is f of y into dy over t over the collection of b of a. Fine. Now you can see I take n is 1, which is correct. This is correct option. So definitely this is my wrong, because this is f of x, but we need this one. Okay, now what is that? This is f of, again that's a simple. How you can solve this? X plus y over, this is with respect to the x. Now it's for the all x. So now I can take x plus y is equal to z. So what is that? Dx is nothing but dz. So I can simply take this is f of z dz. So the limit is over the r and r the same. So what is the meaning of that? This option is correct option. Look at this one. This is a t of x. That's a similar of this, but it's a t raised to power n. But we have t raised to power minus 1. So this option is cancelled. So A and C are my right option. So you just simply take, instead of the Rn, you simply work on the R by taking n is equal to 1. Okay, look at this another one. Consider the sequence of the function such that which of the following is continuous function. Your target is to consider the continuous function. So sequence which is a similar of the previous one, I can again take as this one, which is a pointwise convergent, okay, plus which is also the uniform convergent, and it is also the continuous function. But you can see, instead of this, what is that limit of this? 1 by n, which is log of n, so which is not defined. So first option is cancel out. It is also the uniform convergent, but again this is not satisfied. Third option is similar, fn converges to the f uniform convergent, so f must be continuous, so this is correct. There exists a subsequence, so I can take this as my subsequence such that the limits of this are not equal, and this is a correct option. So C and D are my correct answers. Now you can see this is a series. So far we have all discussed about these sequences. So what is the tips for you for the sequences? We always find the limit as n approaches infinity of this. But now we are talking about the series. What is the earlier suggested you, if whenever you are here, you try to find the absolute value of this and prove that it is less than of something. Fine. And if you prove that this is my convergent, then this is my uniform convergent, otherwise not. Now look at that. If I start with this, if I take the absolute value, it is always less than of 1 by n cube, because it's e raised to power minus, and this is a convergent by p test. Fine. So it means yes, this is a uniform convergent. If you take this is my fx, which is always less than of the n raised to power 5, again by p test it is convergent. So this also is correct option. Now if you take about this, which is less than of x, upper value is n, sorry pi, upper value is pi over n raised to power n. So how you can do that is, because of the power n, I can apply the root test. So what is the root test is of this? It will be pi over n. It goes to the 0, which is less than of 1. If it is less than 1, so by the root test it is my convergent. So this is also my correct option. Look at this one. If I start with our absolute value, now because it's a 1 over, so what I can do, x plus pi whole square. So I can simply take any of the sequence from here. It's a minus pi plus 1 over n. I can substitute here. So it will be 1 over n into n whole square. It is my 1. So that means the series is my 1, which is not goes to the 0, hence it is not convergent. Because we all know that the constant series is my divergent. So this is my divergent series. So if it is a divergent, it is not my uniform convergence. So the right answers are A, B and C are my correct answers. Now which is again a sequence. Fine. Then which of the following are true? They are talking about subsequence, pointwise, subsequence. Okay. Firstly, Fn converges pointwise everywhere over the domain. I think it is not. Why? Because if I simply take x is my 1, which is the domain, the series will be my minus 1 raised to power n, which is not convergent. Fine. If it is not convergent, it means it is my not pointwise convergent. Fine. So it means the Fn converges pointwise is a cancel out. Now that rest of the thing they are talking about the subsequences. I think again a very simple. firstly we can, there exist, not for all, there exist a pointwise convergent subsequence of this. So it means your target is to basically choose a sequence from the 0, 1 so that the limit will be a unique one. So how you can, okay, if I choose the subsequence as of, instead of the n, I can choose the subsequence of 2n, that is an even series. So what is that? This is x raised to power 2n. So what is the limit of this? If x is equal to 0, the answer will be 0. Fine. If x is 1, it is my 1, and if x lies between 0 and 1, it is my 0. Is it a continuous function? It is not continuous. If it is not continuous, it means it is not pointwise continuous. It's not a pointwise convergence. So this is a subsequence. So there exists a subsequence which is convergent. So we can see the one subsequence which is not. No, this is a counter example. We can't provide the one counter example. So sorry, this we can't say from this example. How we can think about the other? We can think about the example which has a subsequence. There exists a pointwise convergent subsequence. Can we think about any of these subsequence? Any? How you can think about that? Subsequence of this. Okay, we will look about the second part. Fn has no pointwise convergent subsequence. It has exactly one pointwise convergent subsequence. How you can say it is not a continuous. Fine. That okay, fine. This is a pointwise. This is the function. Oh, fine. My mistake. So this is fine. Now, how you can find the pointwise? We have to take this as a limit. I forget to take as a limit. Fine. So what is that? What is the answer of this? When x is equal to 1, it is a 1, and whenever x is open interval of 1 and it's a 0, so clearly says that it's my pointwise, because limit exists for all case, so it is a pointwise convergent. Fine. So it means this is my subsequence. Instead of the n, it is my 2n. It's my subsequence which converges here. So this is the right answer. There is no pointwise convergent, automatically cancel out. He said there is exactly one pointwise convergent. So this is a one pointwise convergent. Can you find any other pointwise convergent? That's again, I can simply take, instead of this 2n, if I consider this as a 2n plus 1, that's odd sequence. So what will happen? It is minus 1 raised to power 1 and x raised to power 2n. Fine. So that is a minus x raised to power 2n. And if you again find the limit of this, it again goes to the same, which is a pointwise, else are here, which is a pointwise convergent. Fine. So it means there is a one subsequence here, there is a one subsequence here, both are pointwise convergent, but he said exactly one. So that's a wrong option. So correct option is only A is my right answer. Okay, which of the following are true for the functions? Okay, which are true for the function? Very simple. We can take the limit x approaches 0 of fx. So sine of x is 0 into of this. So this is a number which is lies between, there's a bounded, is a bounded function. So when you take a 0 into this, is a 0. So that means limit exists and unique. So what does it implies? So that is a limit inf, and the limits both are equal and must be equal to 0. So this value is cancel out. Limit supremum is again a 0, correct option. They are not same, cancel out. They are same is the correct option. So A and D are my correct answers. Okay, now there is a sequences of this. Fx is my tan inverse x. Okay, first option is you need to find the derivative. So derivative is my here. Fine. There exists. can you find any of the polynomial px? When you multiply p into fx, it will be 1. Yes, you can see this is the polynomial. Fine. So first option is correct. The nth derivative of this function is a 0. And okay, first way is you can find the first derivative, f dash 1 over 1 plus x square. You can find the second derivative, it's a minus 2x over 1 plus x square of square. So when n is my even, so that is my this case, when you take at the point 0, it will be 0. But he said for all. So it means we need to check for the fourth derivative, we need to check for the sixth derivative, and so on. So the easiest way, I can open this series. What is the series of this? X raised to power 3 over 3, x raised to power 5 over 5, and so on. So I can write this series as of a raised to power n, x of n, where an will be my, if you compare, minus 1 of, is the odd 2n plus 1 over 2n plus 1. Fine. Also, we all know the relation between this coefficient of the power series with respect to the derivative. This is nth derivative at the point 0 divided by n factorial. Fine. This is the rule. Now clearly says what is my a2. a2 is my 0 because coefficient of the x square is 0. a4 0 and so on. So that means this is my 0. So if this is my 0, what is the meaning of that? F of even power is my 0. So I can written as 2n. So nth derivative when n is even is my 0 for all n. What about this? It is for all n. So clearly says what is the first derivative at the point 0? It is a 1, which is non-zero. So this option is cancelled. Now you have to prove whether it's a bounded or unbounded. We can see here. So it's a odd number, 2n plus 1. What is the value of the a of 2n plus 1? This is a minus 1. So basically this is an odd number. So I can return this as 2n plus 1. From here I can find the value of 2n plus 1 at the point 0. So a of 2n plus 1 into 2n plus 1 factorial. Fine. So if you open this bracket, if you substitute here, it will be minus 1 over 2n plus 1 into 2n plus 1 factorial. Clearly says that it goes to the infinity because this has a higher power. So what is the meaning of that? This is my unbounded sequence. So your target is to formulate a sequences of this which is a unbounded. Why I consider only the odd power? Because odd power has here, even power is a 0 value, odd power has some value, even power has a 0 value, and so on. So that means the odd has the unbounded sequence. So this is the unbounded. This is the correct option. A, B, and C are my correct answers. Okay, look at this. Another one. F is again a sequence. Fine. Whenever there is a sequence, try to find this firstly limit. What is that? So as n approaches infinity, it is my 0. So which is my pointwise convergent. Fine. Then for the uniform convergent, we have to take this x square minus 0 over this domain. Take the denominator as a 0. We can easily get the value of the x is my 1 by n. So if I substitute here, this value will be 1 over 2, which is not goes to the 0. It means it is not uniform convergent on x belongs to the R. So that means whenever n approaches, it's a 0. That means all those x which contain 0. Fine. It's a pointwise convergent on the 0, 1 to the continuous function. First option is the correct option. Fine. Look at the another one. F is a convergent uniformly on the 0, 1 is the correct option. F is a uniform convergent 0, 1 and half, 1. We need a 0 here. How you can make? Because these are the two. In this case 0 contained. In this case 0 does not contain. So what is the meaning of that? Okay, how you can say f convergent uniformly? How you can say? Okay, so okay, I can think about here. Supremum, firstly, x belongs to the 0 comma 1 of 1 plus n square x. Fine. Now if I take x is denominator as a 0, x is 1 by n, which goes to 0 and it belongs to the interval 0 comma 1. So this value will goes to the half, not goes to the 0. It means it is not uniform convergent which contains the 0. It contains the 0, this option cancel out. Now since it does not contain the 0, so it means I can't take this derivative. So what is the meaning of that? This is my supremum of all those x half comma 1 over this case. So in that case you are unable to take this sequence. Fine. Now we all knows this is my monotonically decreasing sequence. Fine. So once it's a monotonically decreasing sequence, it converges to a 0 on this interval half comma 1 as n approaches infinity. Why is it decreasing? If you take the derivative, it will be less than 0. You can see the derivative will be here, which is a less than 0 for all x. So it means it's a 0 whenever n approaches infinity. 1 over infinity is a 0. So mn goes to the 0 over this domain is the correct option. Now look at this option. Limit integration of this. What is the integration of this? I can rub this side. What is the integration of the fn? So it's a 1 over, it is tan inverse x, okay, 1 over n square x square of dx. So what is the integration of this? It is nothing but tan inverse. I can divide and multiply by n square. Fine. This is my here. Clear? So I can take 1 over n square is outside. What is the integration of this? 1 over a tan inverse x over n. 1 over n, sorry. Fine. So what is that? It's a 1 over a. So what is a 1 over n cube tan inverse of nx. So what is the integration over the 0 comma 1? So it's a tan inverse n over n cube and 0 will be 0. So what is that? If you take the limit n approaches infinity, so it's a L'Hopital rule, it's a infinity by infinity, 1 over 1 plus n square, 3n square, which goes to the 0. So this value will my 0. And what is the value of this? So if you firstly take f of x, limit f of this, it is my 0. So integration of 0 is also my 0. So it's my correct option. So C, A, C, D are my correct answer of the problem. Okay, look at this another one. Again, it's a sequences of the function. So you firstly find the value of the fx. Take n approaches infinity is a 0. For the sequence of the g, what is that? It's again a 0. Fine. So what is the meaning of that? Both are my pointwise convergent. Now they are talking about converges uniformly. So define the m over the domain of fn minus f. So supremum of 1 over 2nx plus 1 of 0. So now take the denominator as a 0. You will get x is 1 over 2n. So this value will be my supremum of 1 over 2. So that is my not goes to the 0. So it means this is my uniform convergent, wrong option. Now look at this. If you define here is a supremum of x, gnx, x over 2nx plus 1 minus 0. Again I can take x is my 1 over 2n. If I substitute this value here, so it is my 1 over 2n divided by 2. It goes to the 0. So therefore G is my uniform convergent, F is not uniform convergent. So the first is false, second is true, correct answer. First is false, also the correct answer. First is true, wrong answer. Both are true, wrong answer. B and C are my correct option of this example. Okay, look at this another one. Fn is the sequences of the real function such that Fn is my decreasing sequence and f of n converges to the 0 uniformly. Fine. So we can define the g such that of this one. Then which of the following is my uniform convergent pointwise here? Okay, now it's a series. Look at that. You are talking about the series. Fine. So how you, which term come in your mind when you take the series product of the two series? You can apply either as a Dirichlet test or as a Abel test. What is the Dirichlet test? If you take the product of the two function un and vn, if you prove this one part is my monotonically decreasing and goes to 0 and this part is my bounded, then by the Dirichlet test this h is my uniform convergent. Fine. Now you can see that. What is the fx? This is my monotonically decreasing. Fn converges to the 0 and we all know this is my bounded sequence. Fine. So by the Dirichlet test this g is my uniform convergent. Fine. So the second option is my correct option. Now look at that. It's not a pointwise. Once it's a uniform convergent, it implies it is my pointwise convergent. So G is need not convergent. So this option is cancelled out. What is that? It implies it's a bounded. Every uniform convergent is a convergent. It is also a convergent. It's a uniform convergent. So uniform convergent also implies it's a bounded convergent. So it's a bounded also. This option is also correct option. It's a Cauchy. Once you prove that it's a uniform convergent, so every uniform convergent is my Cauchy sequence convergent. So it's a Cauchy sequence norm is also the correct option. Remember, whenever you prove that it's a uniform convergent, it is a convergent, it is a bounded, it is a pointwise, it is a Cauchy as well. Fine. So need not be, that's a cancel. So answers are A, B and D are my correct options. Okay, look at this another one. Again you can see for the B we can apply the Dirichlet test. Fine. This is my bounded. Fine. And if I prove that this is a decreasing and is a convergence to the 0, then we can see the right answer. How you can see? We can see from the first part. Fine. Now this is the series. So can you find this is less than of something? This term is less than of something? Not an easy target. So we can find the Sn, that's a nth sum partial sum sequence. So n is equal to 0 to n. Fine. So what is that? 1 minus x will be common. So rest of the part will be here. So what is that? This is a GP series. So what is the geometric series? A 1 minus r raised to power n divided by 1 minus r. So it is cancel out 1 minus x raised to power n. What is the limit of this Sn? When x is equal to 1, it's a 0. When x is equal to 0, it is a 1. When it lies between 0 to 1, it will be my 0. This is the limit. What is the meaning of that? It is my continuous. Fine. If it is continuous, it means this series x raised to power n is my convergent uniformly. So what is that? It means a of x is my convergent uniformly. So a converges uniformly, both converges uniformly, converges pointwise. If it is converged uniformly, what it means that it implies it is also convergent pointwise. Fine. The first point is clear. Now we have to think about, now it converges uniformly. Fine. So what is the limit of this? How you can think about that? Now we have to think about this one. So this is bounded. You need to prove that whether it's a decreasing or not. Fine. You only need to prove whether it's a decreasing or not. That's again a very simple, I think. If I consider this one, x raised to power n of this. If I consider this is my b of here, clearly says over the closed interval this. What is my b of 0? 0. What is the b of 1? 0. And otherwise, if I take the summation of this, it will be, what is the sum of this? It will be, how you can find the summation of this? So 1 minus x will be outside. It is my minus x raised to power n. Fine. It will be my, again I can find the nth partial sum sequence. So it is 1, a will be 1 minus r raised to power n over 1 over this. So if I take the infinite sum, it will be 0. So it is 1 minus x over 1 plus, which clearly says it's a decreasing sequence. Fine. So what is the meaning of that? It is a decreasing sequence. Fine. It is a convergent. Fine. By this is my uniform convergent. Fine. So A, B both are my uniform convergent. Can you say this is a uniform? Is it correct? What is that? No, this is a limit. This implies this is a pointwise, because limit existence. Limit is a nth partial sum sequence here. Can you say this is a continuous limit existence for all x? Is it true? This is 1 minus xn. No, sorry. Limit exists. Fine. This is a limit exists. Is it a continuous limit? No. This is not a continuous. You can see that at x equal to 0 is a 1 and upper limit will be, is not a continuous. If it is not continuous, it means it is not uniform continuous. It is only the pointwise convergent. That's fine. Limit exists. It's a fine. It's a pointwise convergent but not uniform convergent. So ax is my not pointwise, not uniform, but b is my uniform convergent. So a and b both are my converges pointwise, correct? Because if it is a, by the Dirichlet test is a uniform, it implies pointwise. This is a wrong option. A converges uniformly, correct option. Wrong option. B converges uniformly but A does not is the right answer. So A and D are my correct option of the problem. Okay, look at this another one. Suppose fx is a sequence of the real function, is a sequence again. Suppose if converges, fn converges to the f on the closed and the bounded. Closed and bounded means on the compact set. Fine, not for the all R, only on the compact set. Then which of the following is here? Okay, look at the first. Fn converges f uniformly on the R. It is on the closed and compact set. Case compact, it is given but it is not. Okay, you can simply take any of the function which is here, closed and bounded. I can simply take of this where x is in my R. Fine. Now clearly says, is it a closed and bounded? What is the absolute value of this? This is my of here. So if I take this is less than of m over n whenever x is in my closed and bounded. Fine. So it goes to the 0. That means it is my, this property is satisfied. Then is it a uniform convergent? It is not uniform convergent on R. Why? Clearly says that x over n whenever x belongs to the R is my unbounded, because x is in my R. If x is in my closed and bounded, that is a compact, then we can say it is a less than m, but it is not true. So it is unbounded, so it means it is my not UC. So the first option is cancelled. Fine. Now second one. Is it a pointwise convergent? How you can say whether it's a pointwise convergent or not? Okay. What is the given of that? Fn converges to the f on the closed and the bounded. That's a compact set. It's a uniform convergent. It is given that once it's a uniform convergent, what is the meaning of that? Fn converges to the f pointwise. So this is already given to you in the statement. So this is my correct option. For the sufficiently large n, f is my Fn is my bounded. I already proved that f is my unbounded, so this is also the wrong option. For sufficiently large n, function is continuous. So we all know, since the function is not bounded, what does it means? That function is not continuous, because every continuous function is my bounded function, but not bounded function implies not continuous. So this option is also cancelled. Right option is only B is my right answer. Look at the another one. If C0 is the space of all the continuous functions such that limit of this f as x approaches plus minus infinity is my 0. Let C0 be equate with the norm, which is the uniform convergent, such that it means this is my uniform convergent is given to you. Which of the following statements are my correct statement? Fine. If Fn is on the compact set, I can take again the same example. Fine. If I say x is in my compact set, k is my compact, then clearly says Fn converges to the f uniformly on this compact set. Can you say Fn converges to the f0? Not true. Always look at the same example here. Fine. What is the Fn? Minus f. It is my x over n, which is not always 0 as x belongs to the R, because this is my unbounded. Once this is unbounded, it can never be goes to the 0. First option is my cancel out. If this goes to the 0, then f converges uniformly on the compact set. It's a correct option. Fn converges to f uniformly on the compact set if and only if this hold. Can you say if and only if? I think this is the example, because it is given that if I again consider this example. Fine. Clearly says Fn converges to the f on the compact set, but we already proved that this is not goes to the 0. So if and only if not satisfied. Neither of the following statement Fn converges f uniformly and implies each other. That's a wrong statement. If this goes to the 0, then this is a compact set is the correct option. So B is my correct answer. Okay, look at this another one. What is that? Again, it's a sequence. This is my given as x raised to power k 1 plus x of square. For all x is greater than equal to 0 and k is my greater than equal to 1. Which of the following statements are correct? For each k, the function is bounded. For each k here, look at that. For each k, I assume k is equal to 1, because there is lower limit is my 1. Fine. So what is my f of x? It is my x over 1 plus x square. Fine. Then we will firstly check about this integration. What is the integration of this part? So how you can do? I can simply add plus 1 and minus 1. Fine. So it will be 1 over 1 plus x and 1 over 1 plus x square over the limit 0 to infinity. Clearly says that this not exist. Why? Because the integration of this will be log to the base of e 0 to infinity, and at the point infinity it does not exist. It means this integration does not exist. That means, but he said finite. So this option is cancelled. Fine. Now for each k, the function is of the bounded variation of the compact interval. What is the meaning of the bounded variation? If you prove that their derivative is bounded less than of the m, if you prove that, it means it implies f is my bounded variation. Clear? If you prove that f is my differentiable function, if you prove that f is a differentiable function and the derivative is less than m, then it implies f is my bounded variation. Okay, another one is, okay, firstly we need a derivative. So let's start with the derivative of this. For each k, let's say k is equal to 1. This one, what is the derivative of this? I can simply take of this minus 2 over 1 plus x cube of this. Fine. I can take 1 over 1 plus x square as a common. It will be 1 minus 2x over 1 plus x. It is 1 minus x over 1 plus x cube. So clearly says that it's a differentiable function at this point. Now what is that? Can you say this is a less than of something? You can see it is a 1 over here minus x over this, which is less than of 1 plus x of this number, and it is on the compact interval. If you take the compact interval, so this number is a x is a closed and bounded, so it will be less than of the m. So what is the meaning of that? F is my bounded variation. So this is my correct. Or if you write in terms of the k, so what will happen? It's a x raised to power k. So this is the x raised to power k, then k times of this, again it's a bounded variation. Now the C part, you need to check about this integration of the limits, and the D part is the sequence converges uniformly. Okay, so firstly we can check whether it's a uniformly or not. Okay, we can take here. So what is the limit? Sequence, we can check about this limit as k tends to infinity. Sequence over the, okay, so clearly says what will happen if k is equal to 1. Fine. Now k, there is no restriction of the k, so we have to take the limit of this. If I take x is equal to 1 firstly, fine, what will happen? It's a 2, it's a 1 raised to power 1, it's a 1 over 4. And when x is not equal to 1, its answer is 0. Why? Because k is my grid. If I simply take k is equal to 3, then the function will be x cube over 1 plus x square. Since the degree of this is my grid, then so it goes to the 0. Fine. Now what is the answer of this? As x belongs to this one, so is it continuous function? It is not continuous. If it is not continuous, what is the meaning of that? It is not pointwise. It is not pointwise means it is not uniform convergent. It said converges uniformly. Fine. Now look at the last option. What is that? Limit of existence. Okay, find limit of xk 0 to 1. I can also take like of this. You know why? Because by using the dominant convergence theorem, we already proved that it's a bounded variation on the compact interval. What is the limit of the f of k? It's a 1 by 4 only. Fine. So what is the limit of this? Is it existence over the 0 1? So if x is 1 and x is in 0 1, so what is that? This is 0 1. When x is lies between 0 1 is a 0, so this value is my 0. He said limit existence, so that's a correct option. So whenever x lies between 0 1, what is the limit of this? You can simply take 1 over n and 1 plus 1 over n. Clearly says that it goes to the 0 is the right answer. So you can see the limit is 0, so C is my also correct option. Okay, look at this another one. Which of the following is a sequence again? Fine. So your target is to firstly find this as of this limit for the first part. What is the limit of this? Fine. X is the 0 1. If x is 0, is a 0. Fine. If x is equal to 1, what is that? If x or otherwise is there. If 0 comma 1. Fine. So what is that? Is it a continuous function? It is not continuous. Not continuous means it is not piecewise, pointwise. Not pointwise means it is not my uniform convergence. It's a uniform convergent. Cancel out. Moreover, if you think, I will tell you another way how you can find the limit of this. You can see x is lies between 0 to 1. You may think about any of the term like of 0 plus 1 by n or from the upper limit of this case. Now if I take from this side, what is the limit of this? It is my e raised to power minus 1, which is not goes to the 0. So it means this is my not convergent. So this is not uniform convergent. So if xn is not uniform convergent, so this part, what is the answer of this? If I take here e raised to power minus 1, 1 plus e raised to power minus 1, again not goes to the 0. So this is again not uniform convergent. Look at this one, e raised to power minus 1, 1 plus n times e raised to power minus 1, which goes to the 0. So this means this is a uniform, but he said not. So this means this option will also cancel. Only right option is my B. How? Because this is my e raised to power minus 1 ln of n plus 1, which goes to the 0. So therefore this is my uniform convergence. So this is the right answer of this problem of this here. So you can see with the very simple tips you can solve this like manner here. We will see the next lecture on the diagonal matrix of the linear transformation. Till then you can simply join my WhatsApp group. I hope you can like, share and comment on my video. Best of luck students. Happy learning all.